Hi everyone. In last session, we have discussed about some formulas like number of orbitals present in given shell n equal to its n value only. Then number of subshells present in given shell equal to n square, means number of subshells in the sense orbitals, or we can say subshells, n square it is. Number of subshells present in given shell equal to n square. Then maximum number of electrons present in given shell equal to 2n square. These formulas were discussed in last class. Today we'll discuss about what is valency shell, what is valency before shell, means penultimate shell, then anti-penultimate shell, and about electron configurations we'll discuss today. Here, valence shell. Valency shell means simply we can say outer shell. Valency shell means it is outer shell. For example, so this is the nucleus of an atom. Then this is the first shell, this is the second shell, this is third shell, this is fourth shell, for example. So here this fourth shell is now I am considering as valence shell, last shell. This fourth shell I am considering here as the last shell. So that last before this third shell, this is the third one, this is second, this is first. So different shells. This is the nucleus. At the center, there is a nucleus. Then after first shell, second shell, third shell, fourth shell, in which electrons revolve around the nucleus. In this particular shells, we have subshells. Subshells. S subshell means orbital. S orbital. Here S subshell means 2s orbital and 2p orbital, p subshell. Like that we have different subshells. Okay. Here valency shell is nothing but the last shell or orbit. The last shell or last orbit present in a given atom. Last shell or last orbit present in given atom is called as valence shell. Otherwise, one more name also there. This is also called as ultimate shell. It is also called as ultimate shell, and it is represented by n. It is represented by n. Small n. N equal to 1 means first shell. N equal to 2 means second shell. N equal to 3 means third shell. N equal to 4 means fourth shell. But here particularly valence shell is represented by n. If n is valence shell, then we have one more term, that is penultimate shell. Penultimate shell is nothing but it is last before shell. Penultimate shell is nothing but last shell, last before shell. The shell which is present before last shell. The shell present before last shell or ultimate shell. Here ultimate, from that only we have penultimate shell. So the shell present before last shell is a penultimate shell and is represented by n minus 1. It is represented by n minus 1. If last shell is 4, penultimate shell is 3. That means 4 minus 1 is nothing but 3. Similarly, we have one more term, that is anti-penultimate shell. Anti-penultimate shell. Anti-penultimate shell means is nothing but n minus 2, we can say. The shell before penultimate shell. The shell before penultimate shell. The shell present before penultimate shell is called as anti-penultimate shell and is represented by n minus 2, n, n minus 1, n minus 2. Here if n equal to 4, n minus 1 penultimate shell is 3, anti-penultimate shell is 2. So if n equal to ultimate shell, that is 4, penultimate shell is 3, anti-penultimate shell is 2. So this you have to remember. Then we have some more terms. There are valence electrons. Valence electrons. Valence electrons means simply based on this. The electrons present in outer shell. Electrons present in outer shell are called valence electrons. This information is useful for further understanding further concepts. So you have to remember what is valence shell, what is penultimate shell, what is anti-penultimate shell. Is out valence shell is nothing but ultimate shell only. Then from ultimate shell term we have taken penultimate. Penultimate means before ultimate. Anti-penultimate means before penultimate. Valence electrons means electrons present in outer shell are called valence electrons. Okay. Then we have one more term, that is core electrons. Core electrons. Core electrons are nothing but the electrons present in inner shells. Electrons present in other than outer shell. Otherwise, electrons present in inner shells. Electrons present in inner shells or inner orbits. Other than outer orbital means what? Inner. Means if electron is present in here fourth shell, that is nothing but valence electron. Electrons which are present in third shell or second shell or first shell, all these are core shells, and the electrons if present in first, second shell and third shells are called as core electrons. Valence electrons means electrons present in last shell. Here I drawn 1, 2, 3, 4 shells. Among those the last one is 4. So that is ultimate. The electrons which are present in this shell is nothing but valence electron or outer electron. The electrons which are present in third shell or second shell or first shell are nothing but core electrons. That is core configuration or core electrons. So these terms also we have to remember. Then after, if you know about this, then we can go for next, that is electron configuration. Next heading is electron configuration. Electron configuration means what? It is simply arrangement of electrons in different orbitals. Arrangement of or distribution of electrons or arrangement of electrons in different orbitals in given atom. Atom contain how many shells and how many orbitals? It depends on the particular atom. Depends on particular atom based on electron configuration. Otherwise, simply we can say this thing: number of shells. Otherwise, orbits. Number of orbits in a given atom. In a given atom, generally is infinity. How many shells are there means 1, 2, 3, 4 up to infinite level we can say. Because if you want to remove electron, we have to give some energy to that particular atom. For example, here this is energy level, here one electron is present. So if you give energy to this, if it absorbs energy, then it can move to next energy level, next energy level, next energy level. If you give sufficient amount of energy, suitable amount of energy, then it first goes to infinity level. From infinite level, it can move out. Like that we can remove electron. That means any atom or any element, if you take how many shells are present means, in this way we can say number of shells are equal to number infinity level, infinity, we can't count. Similarly, number of orbitals, number of orbitals in given shell equal to n only, so that number of orbitals also equal to infinity, we can't count. But in our periodic table, number of elements till now discovered are 118. There is a space in our periodic table for 118 elements. For writing electron configuration of 118 elements, this many infinite number of shells are not required, or infinite number of orbitals are not required. So, as per the number of elements till now discovered, there is a limited number of shells, there is a limited number of orbitals are required. So, here as per our elements in the periodic table, number of shells or orbits required are 1, 2, 3, 4, 5, 6, 7. 7 shells are enough for writing electron configuration. Because of that reason only, in our periodic table there are 7 periods. And number of orbitals, how many orbitals are enough writing electron configuration for 180 elements? Number of orbitals, you know, s orbital, then p orbital, then d orbital, then f orbital, then g orbital, h orbital, like that we can say 1, 2, 3, 4, 5, 6, 7, 8, like that how many shells are present, that many orbitals are present in that particular shell. See, for example, this is the first shell, number of orbitals is 1s. Second shell, number of orbitals are 2, 2s, 2p. Number of this is the third shell. In third shell, we have 3s orbital, 3p orbital, 3d orbital. Fourth shell, 4s orbital, 4p orbital, 4d orbital, 4f orbital. Fifth shell, 5s orbital, 5p orbital, 5d orbital, 5f orbital, then 5g orbital also. G, H, like that we can move. So, this is the number of shells, the number of orbitals which are required for writing electron configurations for the known elements. 118 elements are there. For writing electron configuration of 118 elements, these are the requirements. Then, whenever energy is given to the electron which is in these particular shells or these particular orbitals, then based on the given amount of energy, they may move from this energy level to higher energy levels. Means 8th, 9th, 10th, 11th. Finally, it move to sufficient amount of energy if you give. Otherwise, suitable energy if you provide, then the electron which is present in any of these orbits or any of these orbitals may exit to infinity level. So that I given here number of shells present in given atom is infinity, number of orbitals also infinity. This thing you have to remember. Now I am writing here what is electron configuration. Electron configuration is nothing but what? EC, electron configuration. This is fundamental. About electron configurations, if you don't know, there is means all concept which are present in chemistry depends on electron configuration almost. If you don't know about electron configuration, writing electron configurations, then atomic number, then there is no use. Means it is not at all possible to understand the concepts. If you are not understand the concept means so it is very difficult to understand. Very means other concepts also it is not possible to understand. So this is the basic thing. So electron configuration. Electron configuration. Electron configuration means it is nothing but distribution of electrons. Distribution of electrons in various orbitals. Distribution of electrons in various orbital in given atom. Given atom is nothing but electron configuration. What is electron configuration? It is distribution of electrons. Otherwise, we can say systematic arrangement of electrons. Systematic arrangement. Systematic arrangement of electrons. Systematic arrangement of electrons in various atomic orbitals. In various atomic orbitals. Systematic arrangement of electrons in various atomic orbitals in given atom. Any atom you can take. Any atom you can take. That is nothing but electron configuration. This electron configuration, writing electron configurations, otherwise distribution of electrons in various orbitals or systematic arrangement of electrons in various orbitals depends on different rules. Electron configuration rules we have. Among those, first rule is Aufbau principle. First rule is Aufbau principle. How these electrons are enter into different orbitals in given atom is decided by Aufbau principle. Aufbau. Aufbau rule, Aufbau principle. It is simply the meaning of the Aufbau is building up. Building up means you have to follow a low level to high level. While constructing a building, is it possible to put a brick in the middle directly? It is not possible. First, you have to put that brick at the base level. Then, after, we have to increase the height. Similarly, here also, when entering electrons in different orbitals, first that electron enter into lowest energetic orbital. After filling completely, it can enter into the electron can enter into other high energy containing orbitals. So, it is nothing but Aufbau principle. The statement I am writing here, in the ground state of an atom or ion, in the ground state, the ground state of an atom or ion, the ground state of an atom or ion, electron fill the atomic orbitals. Electrons fill the atomic orbitals. Electron fills the atomic orbitals of lowest energy before entering into highest energy. Atomic orbitals of lowest available energy levels. Here, in the ground state of an atom or ion, electron fill the atomic orbitals of lowest energy levels before filling highest energy levels. Before filling highest energy levels. So once I'm reading, in the ground state of an atom or ion, electron fill the atomic orbitals of lowest energy levels before filling highest energy levels. What is the meaning of this? Ground state means direct, not high energy level. Direct, the energy of that atom is nothing but ground state before providing energy. See, for example, here one electron is present. Here one electron is present. So this electron which is present in particular shell is nothing but ground state. So if you give energy to this, for example, this is the first shell, it is nothing but ground state only. If you give energy to this, it may move to second energy level. It may move to second energy level. So this is nothing but excited state. There is nothing but excited state or high energy level. So electron first enter into first. After complete filling this first level, then only it can enter into second energy level. After completely filling electrons in second energy level, then it can move to third energy level. This is simply Aufbau principle. But the energy levels are decided by n value and also L value. Here something you have to remember. In chemistry, every day I am telling. In chemistry, first you have to remember something. By using that something, you have to understand further concepts. So here, energies of different orbitals. Energies of different orbitals. Energies of different orbitals decided by their n and L values. N and L values. N you know, This is the energy level. Just again, first energy level n equal to 1, second energy level n equal to 2, third energy level n equal to 3, fourth energy level n equal to 4. This n is nothing but what? N is nothing but 1, 2, 3, 4, 5, dash dash and so on. This is the n value. We can say principal quantum number in atomic structure. In first year atomic structure, you can come across all these things. You'll read these topics in first year atomic structure. Then what is about, sorry, here L? What is the L? L is nothing but other quantum number. L values you have to remember. There you'll get clarity. In atomic structure, we have quantum numbers concept. There you'll get clarity about this L value. L is nothing but actually azimuthal quantum number. Azimuthal quantum number. For this, we have to remember. We have to remember the values of different orbitals. L values are different for different orbitals. What orbitals we have? S orbital, P orbital, D orbital, F orbital. These four orbitals are enough for writing electron configuration of almost all elements which are present in our periodic table. So here writing L value and orbital. Like this, you have to remember this. You have to remember now. L value. Then here I am writing orbital name. Name of orbital. L value and name of the orbital. This you have to remember. Otherwise, name of orbital, L value, like that you can write. Name of the orbital. Here I am writing orbital, then its L value. If it is S orbital, for S orbital, L value is 0. For S orbital, L value is 0. Then P orbital, for P orbital 2p, 3p, 4p, any P orbital, L value is 1. For D orbital, any D orbital, 3d, 4d, 5d, because S orbital starts with first 1s, 1s, 2s, 2p, 3s, like that. P orbital, there is no P orbital in first shell. P orbital starts with second shell only. 2p, 3p, 4p, for any P orbital, L equal to 1. L value equal to 1. Then F orbital. For F orbital, say L value of D orbital is 2. L value for D orbital is 2. F orbital, L value, it is 3. F orbital start with which shell? Fourth shell. 4f, 5f, 3f is not possible. 2f is not possible. 2d is not possible. 1p is not possible. So 1s, 2s, 2p, 1s, 2s, 3s, 4s, any ns. But p is start with second shell. There is no 1p orbital. 2p, 3p, 4p, 5p, like that you can write. D orbital start with third shell, third orbit. 3d, 4d, 5d, 6d, like that we can write. F orbital, there is no F orbital in third shell. 3f is not possible. 4f, 5f, 6f, 7f, like that you can write. So these values you have to remember. These values you have to remember. And if you know n value and L value, energies of different orbitals are decided by one more rule, that is n plus L rule. N plus L rule. This is sub rule of Aubert principle. It is a sub rule of Aubert principle. So n plus L rule. N plus L rule. As per this, here the orbital with more n plus L value. The orbital with more n plus L value is having more energy. Orbital with more n plus n value is more energetic. More energetic. And vice versa. Means orbital with less n plus L value. Less n plus L value is less energetic. Less energetic. So this you have to remember. Orbital with more n plus value. Orbital with more n plus value is more energetic, and orbital with less n plus value is less energetic. Here I'll give some examples here. I'll give some examples related to n plus L. How we can decide the energies of different orbitals. See, here I am taking 1s orbital and 2s orbital. Among these two, which is more energetic, which is less energetic? If you know that, based on that, we can decide first distribution of electrons to which orbital. Is it 1s or 2s? See, this 1, here 2, these are nothing but n values. Yes, here also yes. Here, once you check this tabular form, here for s orbital, what is the L value? 0. So here for 1s orbital, n plus L value, n plus L for 1s orbital is 1 plus 0. Then for 2s orbital, it is n is 2. Already it is there, n value is 2. For s orbital, what is the L value? 0. So that here 2 plus 0. So here it is 1, here it is 2. So as per this, orbital with more n plus value is more energetic. So which orbital has more energy now? So orbital with more n plus value. More n plus L value is for 2s orbital. So that here 2s orbital is more energetic. More energetic than 1s orbital. Than 1s orbital. So from this, what we can expect? First we have to distribute the electrons to 1s orbital. After filling 1s orbital completely, then we have to distribute the electrons to 2s orbital. S orbital means what? You know, one box. Here two orbitals, 1s orbital, then 2s orbital. S orbital can accommodate only 2 electrons. So after complete filling this one box, means with 2 electrons, then next electron enters into S. 2s1 or 2s2, like that. Here we'll write one more example. Taking 3p and 4d. So which is having more energy and which is having less energy? For 3p orbital, for 3p orbital, n plus L value, it is equal to n is 3, L value, this p orbital. For p orbital, what is L value? 1. 3 plus 1 equal to 4. Then for 4d orbital, for 4d orbital, here I am writing n plus L. What is n value? Here 4. It is d orbital. So d orbital n value is 2 plus 2, it is 6. So what is the energy? Order of energy here is 4d is more energetic than 3p. That indicates what? First electrons enters into 3p orbital. After filling 3p orbital, electrons enters into 4d. Among these two, like this we can expect energies of different orbitals. Sometimes we may have some orbitals with the same n plus L value, same n plus L value. In case same n plus L value is there for two different orbitals, then we can consider n value only. So one more important thing here is, in case two orbitals, in case two orbitals have same n plus L value, same n plus L value, then energy of particular orbital decided by n value. Energy of orbital or decided by their n value. Only n value you have to consider. Here more n value, more energy. More n value, more energy. Less n value, less energy. less n value means less energy. Less n value means less energy. For example, here I am taking one orbital, 3p and 4s orbital I am taking. 3p and 4s orbital, these two orbitals. For 3p orbital, n plus L, value. N is 3. P orbital, for p orbital what is the L value? 1. How much it is? 4. Similarly, for 4s orbital, n plus L, value is how much? N value 4 plus L value how much? For s orbital 0. So here also it is 4. So both are having same n plus L value, 3p orbital and 4s orbital. These two orbitals are having same n plus L value. But to which orbital first electrons will enter? First electron will enter into 3p orbital. After filling 3p orbital, electrons enters into 4s. Why it is so? Both are having same n plus L value, but here energy decided by their n values. More n value, more energy. Less n value, less energy. So that among these two orbitals, which orbital has less energy, less n value? 3. This 3 is less than 4, no? So therefore, here 3p orbital has less energy than 4s. These energies. Energy of 3p orbital is less than 4 because in 4th s orbital n value is more compared to 3p, 3. So 3p has less energy than 4s. What it mean? First electron enter into p orbital. P orbital means 3 sub boxes. So that each box can accommodate 2 electrons. So total number of electrons can be accommodated in 3p orbital 6. Means after filling 6 electrons in 3p orbital, next electron enter into 4s orbital. So up to this you have to remember. In next session we have one diagram, Euler's diagram is there. Based on Euler's diagram we have to write energies of different orbitals. Here almost 19 orbitals we have. 1s, 2s, 2p, 3s, 3p, like that up to 7th shell. If you take how many orbitals are required for writing electron configuration of 118 elements? Almost 19 orbitals are required. For those 19 orbitals, what is the order of energies? We'll discuss in next session. Up to then, stay home, stay safe. Thank you.